Hey everyone, here are the notes that you're going to do for section 7.6. You're going to find it's very similar to what we've done or what you did in 7.4, where now we are finding probabilities of p hat, and we're going to have a new way to calculate a z-score. Yeah, so let's just kind of talk about this. You can see on this screen right now that it says that usually we just try to take one sample and we make all decisions or inferences on the basis of those results. So we can still use a mean, standard deviation, and shape of the sampling distribution of p hat to figure out the probability that a given value of p hat would fall within a particular interval. So we're going to walk through a couple of examples. The first one here is you can read, but a nationwide telephone survey, 75% of adults said that college education has become too expensive for most people. Suppose that this result is true for the current population of all adults. We're going to let p hat be the proportion in a random sample of 1,400 adult Americans who hold the said opinion. Find the probability that 76.5 to 78% of adults in this sample hold this opinion. So the first thing we do is kind of think about what do we know. We know P is 0.75, which means Q is 0.25. That's way over here. Our sample size is 1,400. Again, we know that the mean, this should be the mean of p hat, again, is equal to p, which is 0.75. And the standard deviation, again, of p hat, not x bar, is this formula, which would be calculated in this way and give us this value. We also then determine that n times p is greater than 5, and n times q is also greater than 5. Since both of those things are true, then we know that the central limit theorem applies, and we know that the sampling distribution then is approximately normal. If it's normal, then we can use the charts in the blue section of your book or in the back of your book to find some probabilities. So this is, again, what we're kind of looking at. Since we know that the sampling distribution of p hat is approximately normal, it looks like this. The mean was 70.75, so we're trying to find out what percentage of the population falls in this range. Now, this is the way that we calculate the z-score for p hat. And this is a little bit crazy because, I don't know, the symbol somehow got cut off. So this is z equals p hat minus p divided by sigma p hat. So these little, whatever those little things are pieces of the little hat. Okay. So for our example, we will find the z-score that corresponds with 0.765. That's going to be 1.30. We'll find the z-score that corresponds with 0.78, which is 2.59. So we're looking for the probability that p hat falls between 1.3 and 2.59 standard deviations away from 0.75. That's what this really means. We know from past times that we take the probability that z is less than 2.59. You'll find that again on the chart is 0.9952 minus the probability that z is less than or equal to 1.30. Again, find that on the chart. That's 0.9032. And when we subtract those, we get 0.0920. Or what we're finding is that about 9% of adults think that college is too expensive. Or no, there's a 9% chance. Well, let me start over with that. There is a 9% chance that between 76.5 and 78% of adults think that college is too expensive. There we go. And there it says it there. Okay. Here's what the graph would look like with the corresponding z values on it between 1.30 2.59. This shaded area is 0.0920. Okay. The next example, Maureen Webster, who is running for mayor in a large city, claims that she is favored by 53% of all eligible voters of that city. Assume that this claim is true. What is the probability that in a random sample of 400 registered voters taken from the city, less than 49% will favor Maureen Webster? So again, our sample size is 400. The probability proportion there is 0.53, which makes our Q value 0.47. So we can find mu p hat, which is just equal to p itself, which is 0.53. And then we can also find sigma p hat, which is 0.0249, ... Okay. We're trying, well, we find our z-score by taking our we're going to find our z-score by taking our p-hat value. Going back to this, we want to know less than 49%. 49, sorry, I'm on the wrong screen. 0.49 minus p, which is 0.53. Divide that by our standard deviation of p-hat. It's negative 1.60. So we want to find this probability that z is less than negative 1.60. Again, we look at the chart. Negative 1.60 gives us a probability of 0.0548. Hence, the probability that less than 49% of voters in a random sample of 400 will favor Maureen Webster is 0.0458, or about 5.5%. And that, I believe, oh, here is the graph. So you can kind of see what we're talking about, a very small percentage, okay, under that portion of the curve. Okay, so here we go. So hopefully that kind of makes sense. Again, we've been doing that several times for different values, and I think that you guys are getting pretty good at that. So that's what you're going to be doing on your homework today. Your homework is actually pretty short, and this video is actually pretty short, so you should get it all done during class. So here's the assignment on in section 7.6, page 301 to 302. You're going to do 62 through 66 all. Okay. And I will be back with you on Thursday so we can wrap up anything that we need to finish doing in chapter 7. So good luck, and I will see you all on Thursday or Friday. Sorry, I forgot I was doing this for also 8th hour on Wednesday. So I'll be back Thursday and Friday. See you guys. Bye.